Smasho here, coming at you with the daily space weather. And welcome to the Smash News Network, least busted name in news, as we bring you the most detailed space weather and comprehensive solar imagery you'll find anywhere in the world. We've started things out today with some 131 plus 171 angstroms wavelengths from SDO. And, well, we've got lots of sunspots, lots of solar activity in general, some major coronal mass ejections to cover. Are they earthly directed? We'll let you know here momentarily. First, let's take a trip around the horn. Here's the northeastern limb. We may have some new sunspots rising there in the northeast. Northwestern limb, we've got some sunspots that are going to set here in the next about 36 hours. That'll increase their propensity to produce major solar flares. Southwestern limb depicted here. We've got the huge Hulk Hogan filament in the process of becoming a prominence. It's this dark absorption feature you see right here. And also plenty of more filaments over here in the southeast. So a huge number of filaments. We'll cover that later in the video as well in the bonus features section. There is your southeastern limb. And of course, that sunspot group just to the north of that is quite huge. It's got lots of magnetic field complexity. Also, you've got another sunspot group here right across the equator from it. Huge plasma bridging effects happening in this area as a result of that. It's exciting stuff, and let's take a look at sunspots. This is yesterday plus today in SDO intensity gram. So most of these sunspot groups have been stable here over the past 24, although this group here that's just setting has grown a bit. That increases the likelihood of major solar flares. Many of these sunspot groups are larger than the entire planet Earth. Let's take a look at the fields. That's yesterday plus today SDO colorized magnetogram. And it's playing very slowly because reasons. Okay, let's just resubmit that, see if it actually functions. All right, yeah, there's SDO, colorized magnetogram. Again, most of those groups mostly stable for the past 24 hours. Let's take a brief moment to see what's going on Crescent Earth. And we've got some volcanic eruptions here like Sakurajima producing a 7,000-foot ash plume, Subanosejima 6,000-foot ash plume, Semaru 14,000-foot ash plume, and now Merapi back on the list. Possible major eruption about to happen there. Stay about 3 kilometers away, as you could get hit with things like lava bombs out to 3 kilometers from the Verbeek crater. Popocatépetl exploding, a little uptick there in central Mexico. Flight level 230, 23,000-foot ash plume from Popocatépetl. Fuego in Guatemala exploding, flight level 170. Nevado de Ruiz exploding, flight level 230 over Colombia. No volcanic ash currently visible from Sangay in Ecuador, but Cotopaxi there, 24,000-foot ash plume over Cotopaxi, flight level 240, and Sabancaya featuring intermittent emissions. A reminder to not pole vault the caldera. Next, look at seismicity here. This is the past 90 days. Things have been fairly calm here. The largest quake of the past 24 was at Philippines. We're going to scroll up the list and cite quakes larger than a 4.9. So, first of all, we've got a 5.0 here northeast of New Zealand there. It's a not a major quake there. Probably not felt by a lot of people as it is out in the ocean. Tonga also had a 5.3. Just to the northeast of that, Kermadec Islands quake. Indonesia had a 5.0. Papua New Guinea had a 5.2. So it's a little bit of an uptick from yesterday. We had very calm seismic conditions in yesterday's video. Aftershocks continue in Turkey, of course. Things getting more calm there. And that 5.9 at the Philippines came in at 8:55 this morning. So before we get back to space, take a moment to visit the links below the video. If you haven't done so, check it out. The Redbubble shop there is listed. If you click the link, you'll find the products in order of best selling. And yeah, a bunch of merch there that you might find amusing. They make great gift ideas. And of course, some of those products are there because they were requested by our viewers. So again, visit that link. Today's featured product is Mensa, which stands for Make Earth Not Suck Again. So I'm wearing the hat. Here it is. Very high print quality there. Mensa, Make Earth Not Suck Again. It's part of the purpose of our channel because, well, the way to get out of a hole is to stop digging. So also, I am wearing the Smash Team shirt as well. That's a design only available to gold paid-up annual subscribers at the Smash Team. But today's featured product, nonetheless, is Make Earth Not Suck Again. So it is up to you. You need to push back against those who are attempting to make terrible decisions for you. It is part of your role on planet Earth to make it not suck again. So do your part. It's up to you, not giant bureaucracies that can't get out of their own way or do their own job. So Mensa, Make Earth Not Suck Again. There's also a Make America Not Suck Again, Mensa. And if you want to support the channel via subscription services, become a member of the Smash Team at smashomash.com/SmashTeam. The gold annual paid-up subscription, again, entitles you to complimentary merch. It's almost like getting 4 months of a gold membership for free. We've already explained the likely mechanism, the plausible mechanism underlying the solar sunspot and solar polar field reversal cycles. You can also find a permanent link to our Discord chat there on the Smash Team page, as well as on the homepage at smashomash.com. Check out the Smasho forum if you haven't. We've recently put up a new post about ultra-healthy eats, and you're invited to contribute. Most of those services are free. Gold and Silver Smash Team memberships do have a monthly cost. There is also a bronze membership. We do send out email alerts as well. And let's get back to the realm of space. Space, a frontier. These are the voyages of SDO in 304 angstroms. One of the classic wavelengths there. Great at showing filaments and active regions. We'll also show another classic, the 171 angstroms wavelength, a house and crowd favorite. Again, perhaps some new sunspots there rising in the northeast. We see some majorly bright filamentary suspensions happening over there. Right up here. And if you're a new viewer to the channel, we're frankly surprised that you found the channel. If you're wondering why this is called the East and why this is called the West, it's because this is where space weather sets, and this is where space weather rises. It is a heliocentric concept of East and West. We've also added 335 angstroms to the 171 to add some great depth to the solar corona. And let's get into the stats. So here are the data sets. The 10.7 centimeter radial flux is currently at 208 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 joules of radial flux density. It was discovered in 1947 by some Canadian radio users using some World War II equipment. They realized that the sun was emitting a 10.7 centimeter radial flux. Turns out it's proportional to sunspot number, as you can see here on this one-year chart. The black line is the radial flux and the red line is the sunspot number. The blue line down there, that's the AP index, that's the interplanetary magnetic field. 208 solar flux units is the current radial flux. So it's down a little bit from yesterday where it was at 215. Space Weather Enthusiast dashboard here, not forecasting any sort of geomagnetic unrest or geomagnetic storms. That's NOAA's forecast for space weather. We'll let you know later in the video if we expect any coronal mass ejections to be headed our way. Next, Planetary K Index, a measurement of global geomagnetism, is currently calm at 2.67. 2.67 is the KP index. And let's take a look at Earth's magnetic moment from space. So this is the last 4 hours of Earth's magnetic moment from space. It depicts magnetohydrodynamic pressure, or nanopascals. And this is part of the reason why we jokingly state that the Earth is croissant-shaped, because the funniest jokes, folks, are the ones that are true. Anyway, that's the last 4 hours. Things have been pretty steady here. Here is Earth's magnetic moment from the ground. We do see the likelihood of some aurorae. So if you do have aurorae imagery that you'd like to share, join us on Twitter or Instagram. You can find links on the homepage as well as below the video in the description to those social media sites, quote, social media, and quote, sites, as they're about as social as locking yourself in the basement with several bottles of vodka. Nonetheless, we still call them social media sites, despite their antisocial and pathetic censorship nature. That's the last 4 hours of Earth's magnetic moment from the ground. Share your auroral images with the channel, and perhaps we'll even feature them on a video. Next, looking at the real-time solar wind here, and it's been pretty steady over the past about 16 hours. Current conditions are about 7 protons per cubic centimeter for the solar wind density, solar wind speed 480 kilometers per second. Next, looking at magnetic data. The GOES magnetometers here showing some pretty spiky readings. Keep in mind we are still experiencing a high-speed coronal hole wind stream. And during those, we typically see these spiky sawtooth readings from the GOES magnetometers. No real surprise there, as Earth's magnetosphere is being buffeted by incoming high-speed solar protons. Next, looking at the heliospheric current sheet, and Earth lies in a North Pole current sheet here at the moment. That's our top view ecliptic plane field plot, and something very important to notice here, we do see some migration. So if you look at this green blob here, that is the North Solar Polar Field. And it's actually starting to migrate there. So it looks like it's finally starting to sort of leave the North Polar region. Of course, as we approach solar maximum, we can expect the South Solar Polar Fields to be up there in the North Polar region as the solar polar field reversal process happens. You can see quite a bit less North Pole magnetism there in the last few frames. That is the solar cycle progression taking place on our channel right before your very eyes. So here's our line of sight field plot. This depicts the solar B field in blue, North Solar Polar Field in green, South in red. And let's move to the coronal hole line of sight plot next. So we are expecting to see some more well-defined North Pole-oriented coronal holes here, since the solar polar field has continued its migration there away from the North Heliographic pole. We can expect some well-defined coronal holes in the coming days here. And you can even see a little bit of that migration in the final couple of frames there. Right up here, you'll see a little bit of that migration out of the polar region. And let's see if it shows up in SDO 211 angstroms. So here's the past 24 hours, and indeed you can see a bit of definition happening up here. Don't be surprised to see a little plasma reorientation as well around that area, as that coronal hole migrates a little bit to the south. If you're wondering the orientation of these coronal holes facing Earth here at the moment, these are all North Pole oriented. So this is north, these are north, this one up here is north as well. Pardon my terrible N. Next, moving to sunspots, and there are lots. Many of them are larger than planet Earth. Likelihood of major flares very, very high. Yeah, so that's there's our flare monitor, and that's a lot of sunspots. The next name group is going to be 3223. Let us know in the comments if you think a new one will rise up here in the northeast. It looks like pretty much a sure thing, but hey, you never know, the magnetic environment can suddenly change. So here are some views of sunspots from SDO. That's SDO Continuum plus 171. Let's zoom in. And of course, you can see the size of those sunspots in the northwest there in comparison to our Earth scale. Several sunspots here, approaching the size of planet Earth, if not larger. Let's subtract 171 angstroms. There's STO continuum. Again, that is a lot of sunspots. Don't be surprised to see a major flare from this group, or perhaps this group. We've got important stuff to share about the synoptic map here later in the video. Also, we'll talk about sunspot latitudes. Sunspot latitudes. It's super important. Before we get to that, let's take a look at energetic particles, solar flares, and some more imagery. So there are your energetic particles. Proton flux remains flatline, no spikes, despite significant M-class flaring over the past several days. In fact, some M-class flares happening as we did show prep today. So that's your GOES X-ray flux for the past 3 days, and let's take a look at where the activity is likely coming from. And that group we just forecasted as producing some flares indeed did produce one of those M-class flares. So we'll definitely be paying attention to the western limb here as we've got major sunspot groups setting. That significantly increases their likelihood of producing large flares. It's just a statistical reality. And let's take a step back and orient our viewers here to where things are located. So first, a star chart. We're always interested in what's going on overhead. If you want to make your own, head to skyandtelescope.org. And you may see the moon and Spica there close by. If you see a bright star near the moon, that's Spica, just moving into the constellation Virgo there. And you may see Mercury ahead of the sun if you're up before sunrise. Sun just rising here over Lehigh Valley, Pennsylvania. Let's do a solar system forecast. Here's where stuff is now. Earth moving to a very lonely side of the solar system here, devoid of gas giants. We'll advance this 1 week for your astrographic pleasure. Here's where things will be in a week. We'll have a crescent waning moon, and let's take a look at coronal mass ejections. So that's a significant series of coronal mass ejections. Are they headed toward the Earth? That's probably your next question. And don't worry, we've got an answer. That's yesterday's imagery from George Mason University. Here are 2 frames from today. That's not going to show you very much. So let's take a look at our custom imagery here from the Integrated Space Weather Analysis Center. So we've paused this here at 1809 for stereo A on the left, and we've paused it at 1806 for Soho Lasco C3 on the right. Why? Well, it's mainly because of this CME here, this one off to the south. Let me just bring this back a few frames here. You can see that is quite a significant CME. Multiple shell eruptions happening there. You can see these shell-like features. And there may be a component there that's earthly directed, so let's do a little further view of this. Let's bring this back to where we were at 1809. And for you new viewers, Earth would be off in that direction, basically from stereo A's perspective. And if we see a halo from the Soho Lasco C3, it could be an Earth-facing coronal mass ejection. Now keep in mind we've got 2 others happening, including one on the far side and one up to the north. So we've got 3 events happening almost simultaneously here. And if we bring this back, it looks like this one from the south does not include an Earth-directed component. So it looks too far to the south, although it could have a small diffuse component that will strike Earth. If so, it's very minor and very diffuse. Most of that ejecta certainly will miss to the south, as you can see here also in the stereo A imagery. A little bit of ejecta here may be moving down the earthly line. So as far as its east-west orientation, it is like, in terms of being oriented at the Earth in this direction, it is sort of earthly directed. However, it is looking like it's off to the south. So that's my guess. Yeah, I would say not earthly directed. If it does strike Earth, it'll be a very minor component. And let's bring those back and let those play through before we show some more custom images. So very spectacular coronal mass ejections happening here. One straight out of the north, one straight out of the south, and one straight out of the far side. Keep in mind those are not synced. It is 90 frames from each source. Pay attention to the time and date stamps down at the bottom. And here are our custom movies. So this is the past 24 hours, including SDO 304 angstroms and the Soho Lasco C3 and C2. Let's zoom in a little bit closer. Pretty sure that southern CME does not have an earthly directed component. There is no halo to be seen there. It's off a little bit to the west and quite a bit to the south. So 3 separate events happening there and just spectacular imagery, as you may have come to expect as one of our regular viewers. Next, we'll look at filaments, since the likelihood of additional coronal mass ejections is nearly 100%. So keep in mind, folks, you don't need to see sunspots or solar flares to see coronal mass ejections. We've got lots of filaments here. The Hulk Hogan is about to become a prominence. We've got 1, 2, 3, 4, 5 more filaments in the east that could use names. So if you'd like to name filaments after your favorite or maybe even your least favorite living humans, feel free to join us over on Twitter. Let me just explain what I mean. I'll bring up the last frame. Twitter, the place where people think free speech is fixed because they're Elon Musk sycophants, where we invite you to name that filament. So we've got, let's see, 5 filaments could be named over here. This one up here in the northeast, this one down here in the southeast, and these 3 right on the southeastern limb. Looks like a major opportunity to name some filaments. You can also find the link to our Hemp Lucid free samples there, pinned to our Twitter feed. So check it out. If you don't have a Twitter account, why not get one? We're all the way up to a whopping 374 followers, despite having 18.8 thousand tweets, all the right type of hashtags, original content on our own massive web ring, posts daily, etc. 374 followers. Yeah, censorship's not fixed. It's as pathetic and putrid as it was in 2020. In fact, I think it might even be worse, because now it's known and it's still not fixed. So doing a fine job there as CEO of Twitter, Elon. Pardon the sarcasm. Elon has grabbed the mic and done nothing to fix the crime scene that he purchased. Brilliant job there, Chief. Brilliant job. Press like, subscribe, and share if you enjoy the content on YouTube. And thanks to our YouTube subscribers for tolerating the pathetic, putrid, and disgusting censorship on the YouTube website. If you haven't seen our playlists, there are videos not about space weather and meteorology. So perhaps check that out. Playlists. There are even things like lifestyle stuff on there, even gaming videos, product reviews, and lots more. Help us out with clicks. Visit the homepage if you haven't, smashomash.com. Join us on the interwebs. Help support the content with clicks. We need your assistance to keep these videos on people's screens, because we prefer to keep them publicly visible and free for all to view. The likelihood of that keeps dropping, as the pathetic lack of growth on the channel encourages us daily to just stop doing this entirely or put it all behind a paywall. Our latest sponsor/affiliate is Hemp Lucid. Links below the video to that as well. Of course, there's all kinds of deals. Enter the promo code SMASHOMASH10 to save 10% on your order, or just shop via our link. All kinds of solutions there to stress, sleep, focus, inflammation, and more. So check it out. Fantastic products there. More product reviews coming to the channel soon. And thanks to everybody who's picked up Hemp Lucid products. They are doing a fine job. And no, That is not sarcasm. Next, we're going to move into our bonus features segment here. First, a little more imagery. So there's the past 24 hours and a great set of wavelengths to view filaments, 193 angstroms plus 304. Make sure you go join us on Twitter and name those filaments, 5 of them to name over there in the eastern portion of the sun. And if you want to name filaments, you got to do it on Twitter. You can't do it in the YouTube feed or any place else. You can't even do it on the Smash Team site, only on the Twitter feed. So that was the past 24. Here's the past about 2.5 hours. And those M-class flares indeed came from these regions over here in the northwest. I think we have an X-class flare in our future, in our near future, within the next 12 hours. I think we're going to see an X-class flare as these two groups over here are certainly quite magnetically complex. So that brings us to our bonus features. First, looking at satellite charging hazards. We've got some minor surface charging hazards here over the Central Pacific. No big deal. It's by low-energy electrons on the outside of spacecraft. Here is your GOES electron flux, measured at the F layer of the ionosphere using radiography from the GOES 16 and GOES 18's geosynchronous orbits. They orbit at about 23,000 miles of altitude. They're measuring the GOES electron flux at the F layer of the ionosphere. That's the past 3 days. There is the forecast model. NOAA not too far off with the forecast there, and no arguments about that forecast. The green boxes are the forecast. The yellow diamonds are the observations. There's the one-year chart to put it in context. We're just in an operating range here of electron flux. Nothing to write home about there. Let's take a look at the F flare and the vibrational frequency at the bridge between Earth and space. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation into the atmospheric layers, the chemical concentrations of the thermosphere, and temperatures. Meanwhile, let's move on to the ionosphere animations. So this is courtesy of the Australian Government Bureau of Meteorology. Wow, some major high-frequency anomalies happening there. Anyway, we're going to let that play through. That's the previous day. And here's the anomalygram showing anomaly in megahertz from a 30-day median. So you see all that blue there in the western world there over the Americas and the Eastern Pacific rather. Those are the high-frequency anomalies that were super obvious on the ionogram. This is anomaly in megahertz from a 30-day median. Major high and low frequency anomaly swings there, as you may have come to expect from the South Atlantic anomaly, which is now returned to the South American continent. And we'll briefly show the latest image. There is 1215 universal time ionogram, 1215 universal time anomalygram. To give you an idea of what an anomaly is, there's the rock back. And we'll also show the total electron content. It'll show you the most likely places for GPS errors. Feel free to pause on this frame if you're not familiar with distances to certain things in miles, like distances to the Van Allen belts and so on. Here is the free electron content out to about 12,500 miles of altitude. Surprisingly erratic electron contents here. Huge nighttime GPS errors likely happening there, as well as major errors over the North American continent and so forth. Also some weird low-frequency anomalies. Check it out right here. Low electron anomalies happening right in this area. Also over the Caribbean, you see a low electron right there, a low electron content anomaly there, west of South America, popping up. We'll let it play through one more time. We don't want the video to be too lengthy. Those are the most likely places to see GPS errors. Use your Wi-Fi location accuracy. Perhaps if you're navigating, that might help you out. Next, I just wanted to briefly show a synoptic map because of solar latitude. So this is part of our bonus feature segment here. And yeah, what's important to note, and it's been going on throughout this solar sunspot cycle, is that we've got sunspots that are at a very high latitude, way up here toward the poles. We've also got sunspots that are at a very low latitude, way down here by the equator. And we've been seeing that throughout the solar cycle. Now, typically throughout a solar cycle, sunspots migrate closer and closer to the equator. When you get to solar minimum, you only see sunspots around the equator, with the occasional tiny sunspot from the next cycle at very high latitudes. At the moment, we've got sunspots at various different latitudes. It's been a feature of Solar Cycle 25. So that's your synoptic map, one of the many features you can find at the Space Weather Prediction Center. And yeah, again, that's a lot of sunspots. It depicts sunspots, filaments, coronal holes, likelihood of flares, and so on. I think the likelihood of an X-class flare is more like 40%, but let's move on to show the latest imagery from SDO in ultra-high res. So yeah, these groups up here, let's try that again. These groups up here are quite likely to produce major flares. Check it out, there's a light bridge within this umbra here. It's like an umbra within an umbra. You don't see that every day. Anyway, there's the magnetic complexity, beta gamma delta class, beta gamma class. Let's take a look at this group down here as well. That has grown. It is beta gamma class. It could be becoming a beta gamma delta class. And do we have any new sunspots rising yet? Nope. No new umbrae there in the eastern limb. Anyway, there's your rock back, and let's move into the realm of meteorology. We're looking at the world's largest waves. So we've transitioned from space weather to Earth weather, and the planet's largest waves are just south of Iceland here. So we've got some 34-footers down there. Those waves a little bit larger than these North Pacific waves. Also, these, well, no, I might have kicked up now. All right. The world's largest waves there are northwest of New Zealand. So how the situation has changed in the past half hour. And let's switch to our regularly scheduled wind maps. So there you go. There is what's going on as far as surface winds. A strong low here, roiling up the ocean to 34 feet, northwest of New Zealand. And these are the jet streams. We've got a major jet stream divergence happening here in the northern Pacific. Anyway, these are the jet streams of the western world. Got a doubled up jet stream there over North America. And a huge low pressure, an upper level low here. So that's a huge, an upper level high rather. That's an upper level high. That's a counterclockwise rotation over the southern hemisphere there. And here are the surface winds of the western world. Strong offshore winds in the Gulf of Mexico there. Surface winds of the central world looking like this. And these are the jet streams. And let's move on to look at clouds and fog over the Americas. There's what's going on. Shout out to Bruce, the Batman. Yeah, our pal Bruce from Brazil. That's clouds and fog, 3.9 nanometer infrared radiation. Next, our weather.gov map. So it looks like some gale warnings there along the Gulf and Atlantic coasts. Also around Hawaii, we've scrolled down to show you the key. If your location's lit, click your location on weather.gov. Some flood warnings there around the Florida Panhandle and southern Georgia. Here's your GFS 72-hour pressure and precipitation forecast. And Virginia can expect to see some ice. The western portion of the state of Virginia there, around the West Virginia border, expecting some significant icing there. Large portions of Virginia can expect to be coated. Next, we're on windy.com. Windy.com, they've got a great mobile app. Perhaps check that out. We're just looking at the visible satellite interpolation here. Give that a minute to load. It's well worth it. It's some spectacular imagery there. And we're only going to wait so long for that to load. Maybe I'll press refresh and see what happens. Fingers crossed, folks. Press and play, and there we go. Nope. Anyway, that's a current image at least. It's saying it's 2 hours old. Let's move on here. We don't have all day for that to load. Let's take a look at lightning. We did see some lightning here around the Gulf and around Florida. That's our GOES lightning mapper. And frankly, that data looks like crap also. Let's look at a real-time lightning map. And it looks like we do have some activity there in the Gulf. Besides that, things are quite calm here. At least according to lightningmaps.org. Okay. And here's your U.S. Doppler. So there's what's going on in the full 50 states of AUSA, the allegedly United States of America. Here is the lower 48 view. Let's look at clouds and fog. And there is water vapor. Looks like a low forming there over East Texas. I see a counterclockwise rotation beginning. Clear skies over most of the Lone Star State, I would expect, except for the northeastern portion. Anyway, here's your recap. The U.S. Doppler radar for the lower 48. Clouds and fog. And there's your water vapor map. Hopefully that clears things up. Thanks for tuning into the Smash News Network, least busted name in news. If you think it's a dig on CNN, it absolutely is. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.